In this lesson, we're going to factor trinomials when the coefficient of the second degree term is 1. Many trinomials in the form of x squared plus bx plus c can factor into a pair of binomials. So for example, here you have x squared plus bx plus c. If we were to factor that, if there were real numbers in there, it would factor into x plus something and then again x plus something in the other one. In terms of what numbers go there, well, it depends on a lot of factors. So before we get into that though, let's go over our sign rules, because just knowing the sign rules is so important. And it can help you get a lot of problems right on the test just based on the fact of what the signs should or should not be. So let's get started. If the back end of your trinomial is a positive, then that means the signs will be the same. You will have either two positives or two negatives. So here's how you determine. If the back end is a positive, again, the signs are the same. What kind of signs? Well, the middle term will tell you. Since the middle term is positive, that means you're going to have two positives. Okay? In this example, the back end is a positive. Again, anytime it's a positive, it means the signs are the same. The middle term tells you what kind of signs. So here, you're going to have two negatives. Let's do an example to see how this makes sense. So here in this trinomial, x squared plus 6x plus 8. Notice the back end is a positive, which means the signs are the same. What kind of sign? Two positives. Okay, so here this factored into x plus 2 times x plus 4. In another scenario, this trinomial, it has similar numbers, but this time the middle term is a negative. But again, anytime the back end is a positive, the signs are going to be the same. What kind of sign? The middle term tells you it's going to be two negatives. This particular one factors into x minus 2 times x minus 4. If the back end is a negative, then that means that the signs inside the binomial will always be different. So again, if the back end is a negative, the signs will be different. You're going to have a plus and a minus. It doesn't matter which order, which one is first, whether you put the plus first or whether the minus first. You just need to know that the signs would be different. Now the middle terms still tell you something very important. The middle term will tell you the sign of the larger number. Again, regardless, if the back end is a negative, it doesn't matter what the middle term is, but if the back end is a negative, the signs are different. The middle term will only tell you what the sign of the larger number will be. So let's do an example. So here we have x squared plus 2x minus 35. The fact that the back end is a negative, that means the signs are different. The fact that the middle term is a positive, this tells me that your bigger number is going to be the positive one. Notice when it factored into x plus 7, x minus 5, our bigger number, 7, it is positive, just like the middle term told us, which means by default, your smaller number, 5, has to be the negative one. Here's another scenario. Again, when the back end is a negative, that means the signs are different. The middle term tells you the sign of the larger number. This time, the 7 had to be negative because the middle term indicated that it's going to be a negative, which means by default, the smaller number this time is going to be a positive. Now, one thing you should know before starting any method, the first thing you should do when you're factoring a trinomial is to make sure that there is no GCF among the terms. If there is, you have to take the GCF out first. Okay? After you do that, then you're going to go ahead and use your sign rules for factoring to determine the sign within the binomials as well as the numbers. Let's do our first example. Here we have x squared plus 4x plus 3. Notice here the back end is a positive. That means that the signs are going to be the same. What kind of sign? The middle term tells us they're going to be two positives. So then I know it's going to be x plus something times x plus something. So let's go ahead and fill in those x's. And you should note that if in the trinomial the first term is x squared, there's no other way of splitting up those x's except to put an x in one binomial and an x in the other. Because x times x, it does equal x squared. Next, you want to look at your last term. Our last term is a 3. And then you want to look for two numbers when you multiply them will equal 3. Well, there is only the possibility of 1 times 3. There are no other ways in which I multiply it that is going to give me 3. I also want a pair of numbers that if I were to add those same two numbers is going to equal our middle term. So let's test that. We know that it works with multiplying. 1 times 3, it does equal 3, my last term. Now we want to know if we add those same two numbers, will it equal 4, our middle term? 1 plus 3, it does equal 4, and 4 is our middle term. So there is proof that you have the correct pair. Any pair that you decide that goes in the binomial, they have to meet those two criteria. Number one, you're looking for a pair of numbers when you multiply it, it equals your last term. That same pair of numbers, if you were to add them together, it should always equal your middle term. Once you know it meets those two criteria, then you have identified the correct numbers. So now this trinomial factors into x plus 1 times x plus 3. In this example, we're going to go ahead and look at our trinomial. Step 1 is to make sure there's no GCF, and no, there's no GCF. Now we're going to proceed to step 2, which is to look at our sign rules. Remember, if the back end is a negative, that means the signs are going to be different. Our middle term tells us to make sure that the larger number is going to be the negative one. So now it's time for us to look at our larger number to see what is going to go inside the binomials, because we know it's going to be x plus something, x minus something. So you always look at your last term, which is negative 28, and I look for two numbers that when I multiply them together will equal negative 28. So I'm going to look at all the possibilities, and I'm also going to make sure, write it with the larger number, the negative, and the smaller number by default has to be the positive one. So here are the possibilities. 1 times negative 28, it does equal negative 28. 4 times negative 7, it does equal negative 28. So now that I have all the possibilities of getting negative 28, now I want to ask you which one of those terms that if we were to add them together will give me my middle term of negative 3, because remember, it has to meet both criteria. We already know it meets this criteria, these two numbers, these two pairs, of that when we multiply two numbers, it equals negative 28. Now we need to know which one of these meet that second criteria, not both of them, only one of them, to where when we add them together, it will give me negative 3, my middle term. And the correct choice is with the positive 4 and negative 7. Because if we place that in there, it meets both criteria. Negative 7 times 4 does equal negative 28, the last term. negative 7 added with a positive 4, it does equal negative 3, my middle term. So that means it's going to factor into x minus 7 and then x plus 4, because we already knew that it was x's there. We just needed to know what numbers that go with the x's. So again, that's x minus 7 times x plus 4. Does it matter who's first? Whether I put x plus 4 first and then put x minus 7 in the back? No, it does not matter. Let's say you were multiplying two numbers. If you were multiplying 7 times 4, 7 times 4 is 28. If you switch it around and say 4 times 7, it's still 28. So order does not matter when you write the binomials as far as who is first. Okay, let's do this example. Step 1, see if there's a GCF, and no, there's no GCF, so we proceed with the sign rules. Remember, if the back end is a negative, the signs are different. Our middle term tells us the sign of the larger number, so this is saying make sure that the larger number is the positive, which means by default, the smaller number is going to be the negative one. So we know it's going to be x plus something, x minus something. Now it's a matter of just knowing what numbers we're going to place inside there. So we look at our last term, that it always determines it. That's negative 28. So I need to, what numbers, two numbers, when I multiply them together will give me negative 28. And by the way, make sure that the larger number this time is a positive. So write your smaller number with the negative. So here are all the possibilities of how I can get negative 28. And notice that my larger number is positive, just like my middle term tells me it should be. And by default, my smaller number is a negative, as it should be, to produce negative 24. Now I need to know which one of those four possibilities, there's only one, that meet both criteria. When I multiply those two numbers, it gives me negative 28 the last term. If I were to add those same two numbers, it's going to give me a positive 2 the middle term. Okay? So, do you know which one it is? If you said that it was the last one, which is a negative 4 and a positive 6, then you are correct. Because let's go ahead and fill those in and see if it meets those two criteria. Negative 4 times positive 6 does equal negative 24. Negative 4 plus 6 does equal positive 2, which is my middle term. Everything checks out, so it's going to be x minus 4 and x plus 6. And that is what that trinomial factors into. And again, order does not matter who's first. We could have written it as x plus 6 times x minus 4. Now, not all polynomials or trinomials can be factored. Some cannot be factored, where you can try and look for pairs of numbers and you just can't seem to find a pair of numbers that meet both criteria. In that case, we say such a polynomial is prime. So whenever you see the words prime, you are basically saying, hey, this cannot be factored. So make sure on the test that you exhaust all possibilities before you come to that conclusion. Let's look at an example. Okay, so step 1 before factoring is to make sure there's no GCF, and no, there isn't, so let's proceed with the sign rules. Recall, if the back end is a positive, that means the signs are going to be the same. The middle term tells us they're going to be two negatives, so it's going to be x minus something times x minus something. And now it's time to determine what numbers are going to go in the binomial. So you always look at the last term. Here, this is a 10. And I look for possibilities. What are two numbers when we multiply them together will give us 10? Which, by the way, both numbers have to be a negative because that's what the sign rule says. So I'm going to go ahead and write those possibilities. These are the possibilities of how you can get a positive 10. Now we need to make sure that it meets these two criteria. Whatever numbers we choose, when we multiply those two numbers, they have to equal positive 10. When we add those two numbers, they have to equal negative 6, our middle term. So let's start with the first possibility. If we multiply negative 1 times negative 10, yes, we get positive 10. Now let's add those same numbers and see if we get negative 6. Adding a negative 1 with a negative 10 is going to give me negative 11. And that negative 11 is not my middle term, so there's no way possible that first choice could be your pair of numbers. So let's look at the second choice. If we multiply those two numbers, yes, it is going to equal positive 10, our last term. If we add them, however, adding a negative 2 with a negative 5 is going to give me a negative 7, and that is not my middle term. So there are no other possibilities of getting 10. There are no other two numbers that you can multiply and get 10. So therefore, since we've exhausted all of our possibilities and we have not found a pair of numbers that meet both criteria, then that means that this particular trinomial is prime, which means that it cannot be factored. Now, sometimes you'll wind up factoring a trinomial where not only is the front end a squared term, but the back end has a squared variable as well. So we've always seen x squared in the front. In the previous examples, you had just a number, but this time you have a number and a variable as the back end. So what that means is you're going to have to not only split up your x's and have them in both binomials, but in the back end, you have to split up those y's. Since you have two y's, you're going to have to place them in the binomial as well, and it's going to look like so. So you have x's on the front end, and then you have y's on the back end. Which, by the way, if the back end is a positive, that means the signs are the same. What kind of signs? Two negatives. So now we've done almost all parts of it. The only thing left is just to find out what our numbers are going to be, and they will go right in front of the y there. So we look at our back end number of 12. And we want to look for possibilities of how we can get 12, but we have to make sure that both numbers are negatives because that's what the sign rule tells us for the middle term. So both pair of numbers have to be negatives. So let's go ahead and look at all the possibilities of how we can get 12 with both numbers being negative. Now I want you to look at them and think for a moment. Only one of them will meet both criteria. I'm looking for a pair of numbers. When I add them, it's going to equal the middle term. When I multiply them, it's going to equal the last term. Can you think of which pair it is? Okay, did you say the second possibility here, which is a negative 2 and a negative 6? Well, let's plug those in and see if they really work. Negative 2 times negative 6. Yes, it does equal positive 12, my last term. Now we're going to add those same numbers, negative 2 plus negative 6, It does equal -8, my middle term. Since both numbers meet the criteria, it's going to factor into x minus 2y times x minus 6y. And there you have it. We factored the trinomial, and again, order does not matter. Let's do another one. First of all, make sure there's no GCF, and no, there isn't. So let's proceed with our sign rule. Remember, if the back end is a positive, the signs are the same. What kind of signs? Our middle term tells us 2 positives. We also have a squared term in the front end and a squared variable in the back end. So that means we're going to split up those p's in the front and split up the q's in the back. When we do so, it's going to look like so. Last step now is to determine what numbers are going to go there in front of those q's. So we look at our last term is 15, and we want to think of what 2 numbers, when we multiply them together, will equal 15. We also want to make sure that both pair of numbers are positives. So we're going to go ahead and write our possibilities. Here are all the ways in which you can get 15. Now only one of those is going to work. I want to know which pair of numbers, when I multiply them, they're going to equal positive 15. Those same 2 numbers, if I were to add them together, they will equal 8. Do you know which pair it is? So hopefully you said the 3 and the 5, because that is correct. Because when we multiply 3 times 5, we get 15, our last term. If we were to add them together, 3 plus 5, we get 8, our middle term. So we're going to go ahead and put those numbers in front of the q's, the 3 and the 5. And so it factors into p plus 3q times p plus 5q. And again, order does not matter. Now recall the first step in starting any process in terms of factoring is to make sure that you remove the GCF if there's any. So one way you can tell whether there's a GCF, you look at the smallest number. So out of all the terms, the smallest number is a 3. And so what you want to know is, you want to find out, is there a 3 in the other terms? So let's look at the second term. Is there a 3 inside 12? Yes, because 3 is divisible by 12. Is 3 divisible by 96? Is there a 3 inside 96? Yes. So that means 3 is part of the GCF. Now let's see if they share anything else in common. We know they all share 3 in common. How about M? Do they all have an M? Yes. At most, everybody has one M. How about an N? Does everyone have an N as in Nancy? Yes. At most, the smallest one. Remember, you look at the least power, and that's a power of 1. So you know everybody has at least a power of 1. So my GCF then is going to be 3mn. And recall, when factoring out the GCF on the outside, and whatever is left goes in parentheses behind it. And now that we factored it here, we have a trinomial. Whenever you see a trinomial left with the first term being a squared term, and then you have a number multiplied with a variable, and you have a constant number as the last term, that is probably a clue that that trinomial can be factored further. You certainly have to make sure you try. So let's start with our sign rules. Recall, if the back end is a negative, the signs are different. Our middle term tells us here to make sure that the larger number is the positive. which means by default, the smaller number has to be the negative one. So now we need to look for possibilities of how we can get 32. So we want a pair of numbers that when we multiply them, they're going to equal 32. So the pair that would work would be the 4 and the 8. And again, our sign rule tells us to make sure that 8 is the positive one because it's the biggest number, which means by default 4 has to be the negative one. So when we factor it, it's going to factor into n plus something, n minus something. We just found out that it's going to be with the 4 and the 8. So that's going to be, which by the way, there are other possibilities of how you can get 32. I want to make a note of that. But it's the pair with the negative 4 and the positive 8 that's going to work. But yes, mentally when you're solving these, you want to roll different possibilities in your mind. So since the last term is 32, you look for all the ways in which you can get 32, with the bigger number being the positive and the negative, the smaller one being the negative. And then, as I said before, it has to meet that criteria. You're looking for a pair of numbers that if you were to multiply them, they equal negative 32, your last term. And those same two numbers, if you were to add them together, they're going to equal your middle term of positive 4. Just be careful when you're factoring these types of trinomials that you don't look at the original trinomial. Once you factor it, you don't look at the original no more. From then on, you're going to be factoring the trinomial, the second one, which is n squared plus 4n minus 32. That's what we're in the process of factoring. So our pair of numbers, as I said before, it's going to work with the 4 and the 8. You just have to make sure that 8 is the positive 1 and 4 is the negative 1, because that's the only pair that meets both criterias. So when we factor it, it's going to factor into our GCF. Very important that you make sure it's on the outside, because if you leave it out of your answer, it's wrong. So 3mn on the outside, that's my GCF, and then followed by n minus 4 times n plus 8. Remember, order doesn't matter. You could also write it as 3mn on the outside, followed by n plus 8 times n minus 4, because order does not matter. You can even put the 3mn in the very back of both of the terms as long as it's on the outside, because it is the GCF. And there you have it. Let's do one more. So again, we want to look to see if there's a GCF. I look at the smallest number, which is a 4, and I want to know is there 4 in 20, and is there a 4 in 56? So one way you can tell is just divide it. So if you didn't know that 20 divided by 4 is 5, that it divides evenly, and let's say 56, you didn't know what that was, then fine, get your calculator and go 56 divided by 4. And if you get a whole number, then you know it divides evenly. If you get a decimal, then you know it doesn't divide evenly. All right, so we know that there's a GCF of 4, so that's going to go on the outside. Now let's look at the variables and see if everybody has an A. Does everyone have an A? At most, yes. At most, they have one A. So remember, you always look at the least power. So that's a power of 1. So you know that the others have at least a power of 1. So 1A is going to be on the outside. Does everyone share a B? Yes, everyone share a B as well. So my GCF then is going to be 4AB And recall GCF on the outside, and whatever is left goes in parentheses. And again, whenever you factor such polynomials, if you are left with a trinomial where the first term is a squared term, then you have a first degree term, then a constant, you should always make sure that it can be factored. So let's take a look and see. Recall our sign rules. If the back end is a negative, that means the signs are different. My middle term tells me make sure that the larger number is a negative, which means by default, the smaller number will be the positive. I need to look for ways of possibilities of how I can get 14. So we know there are several ways in which you can get 14, but I want to know which one of those ways, if we were to add them, that is going to equal my middle term. My middle term is -5. And so we know it's not the possibility of the one with 1. And usually it isn't the case with 1 whenever you have a composite number. So anytime you have a composite number, usually it's not the one with 1. But if the last term, let's say, was a 3 or a 5, where the only numbers that you can multiply them with is 1, then usually 1 is the case on those. But you just have to try it out, because there are some cases where it is going to be the possibility of the one with 1. Anyway, let's get back to this problem. So the possibility of one in which it meets both criteria, when we multiply the two numbers together, it equals -14. When we add that same pair of numbers, it's going to equal -5. And so we can obviously see it's the second choice, with the 2 being positive and the 7 being negative. And so we're going to factor that, and it's going to go in the back of our GCF. So 4AB as my GCF times A minus 7 times A plus 2. It can also be written as 4AB times A plus 2 times A minus 7, because recall, order does not matter.